Good evening, children. Welcome to 6th standard online physical science class. This is standard 6 physics 7th lesson continuation, magnetism lesson. So today's topic is about magnetic field. What is a magnetic field? The region around a magnet where its effect can be felt is called its magnetic field. Okay, the region around the magnet up to where the magnetic energy is felt, that area is supposed to be called as magnetic field. For this, let us do some activities. Sprinkle some iron fillings uniformly on a thin sheet of glass or transparent plastic. Place the sheets carefully on the top of a bar magnet and tap it a few times. The iron fillings will arrange themselves as shown in the figure. Okay. This provides something like a photograph of the magnetic field. See, look at here. We know that the poles have more strength. So, the iron fillings will stick to the poles. But the other places also, the iron fillings will arrange like this in the other places. Okay. So, this actually resembles the photograph of a magnetic field. Okay, so these areas, this particular area, this area, no, this area is called to be the magnetic field. The area which surrounds the magnet where the magnetic energy is felt, that is called to be magnetic energy. Is it clear, children? Hope you have understood. So now from by this we are going to the next topic, that which is called as magnetic induction. What is magnetic induction? The process by which a piece of magnet material starts behaving like a magnet when it is brought close to the magnet is called magnetic induction. So when magnetic substances, actually they are not magnet, they are magnetic substances. That is, what are magnetic substances? In the other class we have discussed, the materials which are attracted by the magnet are called magnetic substances. Such substances behaves like magnet. When they behave like magnet, when they are when they are get attract to magnet, they themselves behave like magnet. Okay, that is called magnetic induction. See, look at this diagram. A jump clip is attached to the magnet so that it behaves like a magnet. You can test this by placing another jump clip near to it. The second jump clip will also get attached to the first clip. Then the next clip, third one. Take a third clip and bring closer to the second one. The third clip will also get attract to the second one. Okay, that is, the magnetic energy passes through the first clip, then to the second, then to the third. Okay, children, do you understood this? So this behavior is called to be magnetic induction. Do you understood what is magnetic induction? So this magnetic induction can be either temporary or permanent. Okay, this magnetic induction can either be temporary or magnet. Here we have discussed in this example, no, this is an example for temporary magnet. Once the first clip is removed from the magnet, clip is removed from the magnet, what happens? Automatically the other two will fall down because of lack of magnetic power. Okay, we understood. So this is an example for temporary magnet. In the same way we can also make permanent magnets. Let us discuss how. Okay, children. Permanent magnets can be made by using this magnetic induction method. By the steel needle is repeatedly stoked by the north pole of a bar magnet, as shown in the diagram. A steel needle is repeatedly stoked by the north pole of a bar magnet. This means the magnet is moved in only one direction. You should take care of the magnet moves only in one direction. When it is in contact with the needle, then it is lifted and taken to the initial position for the next stroke. So from here, when you start from the right side of the needle, you should travel in this direction alone. The direction should not change. Okay, the direction should not change. Then only the magnetic energy will be there. And after this is done about 30 times, not by simply 1 or 2 times, you have to repeat the same by 30 times, the needle becomes a permanent magnet. So after doing 30 times, the needle will become a permanent magnet, and it has north pole on the right. Okay, the north pole of the magnet will be on the right side. Why? Because we are stroking the needle with the north pole of the magnet, that is from here we are starting, so that from here we are, since we are starting from here, um, the north pole will be on the right side and the south pole will be on the left side. Thus the permanent magnet is made. Okay children, is it clear for you? Hope you have understood this concept well. So this magnet which are made by this method of induction are permanent magnet. Do you understand? The next type of magnet is temporary magnet. We can also call the temporary magnets as electromagnets, since we are going to make use of the electricity or current to make a magnet. Okay, look at the diagram. Here coil, iron nail. Okay, iron nail is winded with the copper wire, and the wire, two ends of the wire are attached to a battery. Okay, they are get attached to a battery, and as long as the current passes through this, okay, as long as the current passes through this coil, what happens, this iron nail, no, the iron nail will behave like a magnet. The iron nail will behave like a magnet, and makes the and attracts the magnetic materials. See here, yeah, iron bolt and a clip is get attached to this iron nail, right? So as long as the current passes through it, it will behave, which will, this iron nail will behave like a magnet. Okay, when you stop the current, when the current passage is stopped, it will loses its magnetic power, and also that is the clip and the bolt will be left down. Okay children, do you understood this? So this diagram also, the second diagram also, here also a safety pin get attached to the magnetic material which is present inside the coil. Okay, why we are using the iron nail here? Why we are using the material, instead of iron nail you can use some iron materials, iron objects. Why we are using iron objects? Because we call this as core. Okay, this is called as the core of the magnet. This is called as the core of the electromagnet. Why? Because why it is made up of iron means this iron does not retain the magnetism. Okay, only when current is passed it will retain the magnetism, so it will not retain. After the passage of current, it will not behave as magnet. And also it can be easily magnetized by small magnetizing field. Okay, so it can get behave as magnet by a small magnetic field. So iron is used. So electromagnet is a temporary magnet, as we discussed. Only when, as long as the current is passed, it behaves as magnet. So it is a temporary magnet. We can even make this as a permanent magnet by, instead of using this iron core material as iron, no, instead of using iron we can use some special alloys or steel, and then repeat the same process, so that these process, unlike iron, they are able to retain the magnetism even after the passage of current. So they will be a permanent magnet. So as long as the iron is used, it is used as a temporary magnet only. If some special alloys and steel are used, it will behave as a permanent magnet. Is it clear children? This is about electromagnet. Is it clear for you? Hope you have understood today's class very well children. So do your assignment, report in the group children without fail. Thank you. Meet you again in the next class.